Alrighty, so check out what I just finished making. This was a disastrous piece of shit. Magnetic ferrous cube is what this is supposed to be, but I used the standard model for like dice cubes and things of that nature. Did not work. So I have a very tiny, very heavy steel cube. So as a machinist, when I spend a lot of time on something like this and it doesn't work, I'm pissed, basically. Like, it doesn't function. It doesn't do the things I intended it to do. Therefore, all of my machining was absolutely useless. So, what I obviously do, as everyone should do, is I figure out a new design. I learned lots about how to, good ways to cut consistent chamfers, on all my cubies. Like, it looks really nice. It turned out looking really nice. But it's totally non-functional. I won't even attempt to turn it, because what happens is, since the magnets, they give a little bit of magnetic properties to the cubes themselves, being that they're steel. So what ends up happening with this is that the magnets are just as, actually more attracted to the steel than they are to each other. But I already have an idea for how I'm going to go about doing a ferrous solid steel cube. Fucker's going to be heavy. I mean, let's see. I did the calculations on how much this thing weighs. And, I gotta redo them. This fucker deleted everything. It's pissed I got low battery, so it's, okay, I gotta remember. 490 pounds per cubic foot for steel, divided by 144, which is, that makes an inch of cubic steel. These are half-inch cubies, so 8 of them make up a cubic inch. So I get, let's see, two. So there's 27 cubies. 24 cubies makes 3 cubic inches, so I multiply that by 3. And then since there's 3 leftover cubies, I multiply that by 3/8 times 3 divided by 8. I end up with roughly 3 3/4 pounds, which is probably closer to real since I milled off the edges and all that stuff. But this, I guess that makes this fucker just under 4 pounds, which, I mean, that's what it feels like, I got my plastic one and my dice cube, and they're both way lighter. And by the way, these are both standard cube size. So just for comparison, it's much smaller. It's actually, oh yeah, I should have known that. It ends up being, if you made a 2x2 out of cubies this size, it'd be this size. Just for reference. I look like a frog sometimes. I learned a lot about what I need to do in the future regarding magnetic cubes. And I don't know if you can tell, like, the finish turned out super cool. All the chamfers came out really consistent. I had some really bad chamfers. Those are all on the inside now. I went through all my cubies and made sure all the really inconsistent or super deep or off-centered chamfers went on the inside. I did try and do something that didn't work. I actually wanted to clamp this thing, and I thought the magnets, being as strong as they are, would hold everything in place. So I clamped it, and I went to take a skim cut so that I could get a real consistent finish on the top of all of them. Because if you look, like, some of them are a little funny looking if I get the light reflecting properly. And it didn't work. The magnets aren't strong enough to hold it in when I got, like, I think I used a 2-inch flat end mill and tried to skim cut one side, and it didn't work. as well as I wanted it to. Which was fine. Like I said, this was a learning experience. One of the reasons it's so small is because I didn't want to waste material. I wanted to find out what happened. And I mean, it does turn. It is technically functional. It's just, you gotta turn it real soft, make sure it doesn't fuck, and then that happens. Since it's attracted to the metal, just as much as it is to the other magnets, you get pieces that are, off. Way worse than the ice cube. And so I think I have a new way of thinking about going about this. One that will work better. And so I'm thinking about the design. I think I have a good one. Like I messed with this one all afternoon and saw all the problems I had with it. Well, I messed with it all day, machining with it, but now that it's actually together and magnetized, and I mean, that motherfucker's never coming apart again. And by the way, you'll never get these magnets back out of here. Even though they're not glued, they're not nothing, they are stuck as stuck could be. Short of drilling holes on the other side and punching them out, like physically, you cannot get these magnets out. So my next design I think is going to work a lot better. I just drew up a quick sketch while I was thinking, and I found some spherical magnets, neodymium magnets, on the internet. So what I think I'm going to do, let's see, this will be my center right here, and I'll actually use a rounded end mill of the same size. I gotta calculate what size I'm gonna use, but it'll be a sphere that sits inside the center magnet right here, and then I'll build a cap, and I'll press fit that cap into the side, so it'll basically look like a solid cube, but it'll be magnetic on the inside, and that magnet will be close enough to all the surfaces that it'll still magnetize. And then so all of my centers, yeah, those are my centers, let me think. So, yeah, all my centers will not be magnetized. The only thing that's going to happen is I'm going to put, I'm thinking a roll pin, but I might just press fit something, like a little solid piece of steel in there, and then have a non-press fit, a slip fit on my centers, so my centers fall on my core, and they can roll around this press fit bit because they're slip fit, and so that'll keep all the centers in line, so they'll rotate and all that stuff. And then my edges will be non-magnetized. I won't even have to worry about my edges, they just have to be machined and be square. And then I'll do the same thing I did with my center, I'll do with my my corners, have this little press fit piece that slides in, so it'll almost look like a solid cube, but on the inside it'll have a spherical neodymium magnet, and that will hold my edges and my centers together. And it means that I won't be attracting a bunch of fucking garbage, like I won't just have tons of chips sitting in there. And you do realize, like, I don't know how many of you do machining, but when something's press fit, you can shove it in, you can find when it's tight, and then you can even it out so it's perfectly smooth, and it'll look very fucking cool. Basically, pull the cube apart, and it'll look like a bunch of cubies. I'll probably even have to mark them, just so you don't get them mixed up, so that I know which ones belong where, because they'll all look the same. They'll all be uniform on the outside. Some of them will have magnets on the inside, and the center magnet's obviously going to be different than the edge magnets, so I'll have to know that difference too. But it'll be a very cool looking cube, and it should function a lot better than this one, but that's an experiment for the future, so we'll see where that goes. This is mild steel, in case anyone wonders. I think it's either 1018 or 1114. I can't remember off the top of my head. The obvious errors of working with magnets in a machine shop didn't dawn on me until I actually did it. So it's a good thing to keep in mind to remember these fuckers attract everything. I mean, any metallic object, and that's even tools you're working with, you know, like trying to clamp them, they just want to go all over the place, trying to use a screwdriver next to them. Every single one of your QBs will just go like, across that screwdriver, and you're just standing there with a screwdriver full of fucking QBs. You're like, this is retarded, you know. It's definitely a different experience, and it's just, you have to be, what's the word I'm looking for? Constantly aware that your magnets will be attracting every single thing you're working with. I mean, even if it's not ferrous, but it's 10 times worse if the stuff you're working with is ferrous. So, just a heads up, it makes them really hard to machine. By the way, they are incredibly hard. I used a regular HHS end mill on it. Every time I hit that motherfucker, it just started sparking all over the place. And yeah, I don't know what the proper tool is to work with magnets, or neodymium magnets. I don't know how to machine them. So that was a learning experience, definitely. But yeah, you want to fuck up some expensive end mills? Try and machine some neodymium magnets with them. It's really stupid. You can't press fit the magnets. I found that out too. That was one of my plans, and the magnets are actually brittle enough that as soon as you press fit them, they don't give, they just crack, you know. But it ended up cracking the magnets, and there's nothing I could do about that. They're almost as brittle as tungsten carbide, which sucks in some ways. But it was me working with the material. I've never worked with neodymium magnets, so I had no idea what their properties are. This one was a lot of work, you know, to machine all 27 QBs to size, because I wanted them to be a little more accurate than if you just buy like a piece of bar stock. And then I machined all the chamfers as well, and then machined all the holes that the magnets go in. To do that probably took me, I don't know, 15 to 20 hours, give or take. This is an involved little project. It was fun. The only shitty part about it was that I got a non-functional cube. It is a block of metal that's going to sit on my shelf, and when people go, ooh, is this a cube? I'll be like, don't fuck with that. You can pick it up, but don't turn it, you know? And it's just itchy beard. It's basically a fucking Christmas ornament from now on, you know? Except it's too fucking heavy to be a Christmas ornament, too, so I can't actually do anything with it aside from, like, bludgeon someone to death. You know, I'm sure if I hit someone with it, being that it's almost 4 pounds, it would hurt like hell, but it basically served no purpose aside from the fact that I learned a ton of shit while making it. Oh my god, it's a fucking block of steel! And all the purpose it serves is as a fucking, you know, paperweight. There we go. Like, you can see how that one in the top left on yours, like top center left, that chamfer is way bigger than all the other chamfers. So, I hope you thought this was cool. If you didn't, you're a fuckhead. That's all I got to say. Later, everybody out in cyberspace.